Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 15th lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our 22nd example, which is a past Kcse question tested in 202, paper 2, question number 24. It reads that the displacement s meters of a particle moving along a straight line after t seconds is given by the equation s is equals to 3t plus 3 over 2t squared minus 2t cubed. So part A of the question, they want us to find its initial acceleration. Remember, initial acceleration will be the acceleration of the particle when t is equals to 0. So initial conditions at the time will always be equal to 0. Of course, the formula connecting acceleration is that acceleration is equals to dv over dt. So clearly, we can see that we shall need velocity in order for us to get the acceleration. And the formula connecting the given equation, that is of s, and the velocity is that velocity is equals to ds over dt. Therefore, we start by getting the velocity of this particular particle. Now, we are given that the displacement s is equal to 3t, then of course plus 3 over 2 t squared, then minus 2t cubed. So for us to get the velocity, velocity is equals to ds over dt, which will be equal to d over dt into, so the s of course is 3t, then plus 3 over 2t squared, then minus 2t cubed. Therefore, the velocity v will be given by, so I differentiate this part here. Of course, it means it was t to the power of 1. So the 1 will pre-multiply the coefficient, so that I'm having 3 multiplied by 1, t to the power of 1. Then we subtract 1 from the power. Then of course the 2 will pre-multiply the coefficient, so we'll have plus 3 over 2. Then of course multiplied by 2, t to the power of 2 minus 1. Then the 3 will pre-multiply the coefficient, so we'll have negative 2 multiplied by 3, t to the power of 3, then of course minus 1. So that means our v will be equal to 3t to the power of 0, then of course plus the 2 and 2 will cancel out, so we'll have 3t to the power of 1, then minus 6t to the power of 2. So clearly our v will be equal to t power 1, of course t power 0 will give us 1. 1 times 3 will get 3. Then of course plus 3t, then minus 6t squared. Therefore, this is our equation for the velocity. That velocity of the particle at any given time t will be given by 3, then plus 3t minus 6t squared. But the question wanted us to have the acceleration. So we know that acceleration is equals to change in velocity over change in time taken, which will be equal to d over dt into our velocity now is 3 plus 3t, then minus 6t squared. Clearly, whenever there is a division by dt, that one is telling you to differentiate. Therefore, our acceleration will be equal to, we'll differentiate the equation for velocity. Of course, this one means it was t power 0. So to differentiate, we pre-multiply the coefficient, so we'll have 3 times 0, t power 0 minus 1. Then the second term, it means it was power 1, so the 1 will pre-multiply the coefficient to give us a positive 3 times 1t to the power of 1 minus 1. Then the 2 will pre-multiply the coefficient, so we'll have minus 6 times 2 t to the power of 2 minus 1. That is, we subtract 1 from the power. So this is going to disintegrate into the following. So we'll have acceleration being equal to, of course, anything multiplied by 0 will be 0. So we'll have 0, then plus 3, that is 3 times 1, you will get 3, then t to the power of 0. Then of course minus 6 by 2, that is 12, t to the power of 1. So a will be equal to t power 0, of course, will be 1. 1 times 3 will get 3. So we'll have 3 minus 12t as our equation for the acceleration. So in part A, they wanted us to get the acceleration when t is equals to 0. That is the initial acceleration. So it means A, when t is equals to 0, or the initial acceleration, will be given by 3 minus 12 into the t being equal to 0. So of course, this will be 3 minus 12 by 0 will give you 0. Therefore, the initial acceleration, the initial acceleration will be equal to 3. The unit for acceleration, we said it's meters per second squared. Or you can also say A is equals to 3 meters second power negative 2. So either of the two is an acceptable solution. Therefore, that was the initial acceleration of this particular body. Then we move to part B of the question, whereby we were told to calculate Roman 1. So this is B Roman 1. We are told to calculate the time when the particle was momentarily at rest. We said that when the particle is at rest, the velocity of that particular particle, which is ds over dt, will always be equal to 0, because at rest there is no change in velocity, that is change in displacement. Therefore, whenever ds is equals to 0, it means that ds over dt will still give us 0. So at rest, the velocity, which is ds dt, will always be equal to 0. Therefore, we are simply going to equate the formula for velocity to 0. So remember, we already have the formula for velocity, which is here. So we'll say that the velocity v, which is equals to ds over dt, which you already have as 3. So this is 3 plus 3t, then minus 6t squared. This must be equal to 0. So I'll pick the second part of the equation, this one here. So clearly you can see it will be a quadratic. So we are having 3, then of course plus 3t, then minus 6t squared being equal to 0, which can be rewritten as negative 6t squared, then plus 3t, then of course plus 3 is equals to 0. So clearly this will give us what we are calling a quadratic equation. We can actually reduce, we can reduce this equation or still deal with it the way it is. So let me just deal with the equation the way it is. So this is ax squared plus bx, then plus c is equals to 0. So clearly the value of a will be negative 6, the value of b will be positive 3, then the value of c will be positive 3. So product is given by AC, which will be equal to negative 6 multiplied by 3, which clearly is going to give us negative 18. The sum is the value of B, which will be equal to positive 3. So by 2, this will give us 9. Then by 3, this will give us 3. Then by 3, this will give us 1. So the two numbers will be, of course, I'll combine these two. So I'll pick 6 and 3 by 1. This will be 3. So my two numbers will be 6 and 3. But I need a product of negative 18 and a sum of 3. To achieve that, I'll put a negative here. 6 by negative 3, you get negative 18. 6 plus negative 3, you get positive 3. So on simplification, this will be equal to, so the original equation was this. So I'll pick negative 6t squared. Then of course, plus I pick my factors, that is 6 and negative 3. Then of course, there was a t. Then I complete my equation. It was a plus 3. That is 3. So this was a t. Then of course, plus 3. This will be equal to 0. So this is negative 6t squared. Then I open the bracket. This will be plus 6t. Then minus 3t. Then plus 3 is equals to 0. I combine the first two factors. I'll factor out negative 6t, so that I'll be having negative and negative will change to positive. So this will be positive t. Then of course, minus 1. Then I pick negative 3 into positive t. Then minus 1 equal to 0. So it means that negative 6t minus 3 then into t minus 1 will be equal to 0. So this one means either we can have two possible solutions. It means that either negative 6t minus 3 is equals to 0. So this is negative 6t is equals to positive 3. So clearly the value of t will be equal to 3 over negative 6, which will give us the value of t being equal to negative a half. That is 6 into 3 into 6. That will be 2 times. Then the second possible value of t, we now use the second bracket here. So we are having t minus 1, which is equals to 0. So clearly t will be equal to 1. But we know that time cannot be negative. Remember, time is a scalar quantity. Therefore, we'll conclude and say at the time when the particle was momentarily at rest will be t is equals to 1 second. T is equals to 1 second. So that is the time when the particle was momentarily at rest. Remember, we are disregarding t is equals to negative a half because time cannot be negative. So we only consider the value of t, which is positive, as our solution. So that is B Roman 1. That was B Roman 1 of the question. Then we move to B Roman 2, whereby you are being told to find its displacement. Displacement by the time it comes to rest. That is momentarily at rest. Remember, at rest, we've seen that the time t will be equal to 1 second. Therefore, we simply get the displacement when the time is 1 second. So this is B Roman 2. So we need the displacement S when time is equals to 1 second. So the formula for displacement S, it was given by, so S was 3t. S was given by 3t. Then 3t plus 3 over 2t squared. 3 over 2t squared. Then of course minus 2t cubed. So this was minus 3t cubed. No, it was 2t cubed. So this was 2 minus 2t cubed. So this was the formula for the displacement. So our displacement S whenever time is equals to 1, that is when the particle is momentarily at rest, will be 3 into our t is now 1. Then of course plus 3 over 2, our t is 1. So we'll have 1 squared, then minus 2 into our t is 1 cubed. So this will be equal to 3, then of course plus 3 over 2, then minus 2. So this will be equal to 3 minus 2, I'll get 1. So we'll have 1 plus 3 over 2. So of course this one is going to give us, this is the same as saying 1 plus 3 over 2 is the same as saying 1.5. Yeah, that is 1.5. So 1 plus 1.5. This will be 2.5. That will be 2.5 meters, which can also be given by S when t is equals to 1 will be given by 2.5. So 2.5 or 2.5 meters. So that is the displacement of the particle when it comes to a state of rest or when it is momentarily at rest. Then we look at part C of the question. We are told to calculate the maximum speed attained. The maximum speed attained. Remember, we had already said that at maximum speed, at speed maximum, at the speed maximum, which is also called V maximum, at the maximum speed or at the maximum velocity, the acceleration, which is dv dt, must always be equal to 0. Because we said that at maximum speed, the change in velocity, there is no change in velocity. The change in velocity is usually equal to 0, or the change in speed is 0. Therefore, at maximum velocity, always know that the acceleration of the particle will be equal to 0. Since we already have the formula for acceleration, the acceleration was, so this one is equals to dv dt, which is equals to, the equation for acceleration, we already have it here. It was 3 minus 12t. So this was 3 minus 12t. So this one is equals to 0. So you can get the timer. So you can say 3, that is on picking the second part of the equation. We'll have 3 minus 12t is equals to 0, which implies that 3 is equals to negative. So when it moves to the other side, it will be positive. So this is positive 12t. So over 12 over 12. So clearly our value of t will be equal to 3 over 12 by 3 1 by 3 4. So our time t will be equal to a quarter seconds, So the particle is going to achieve the maximum speed when t is equals to a quarter seconds. But because we already have the formula for the velocity, or simply the speed, remember we said that velocity and speed are the same thing. The only difference is that velocity is a vector quantity, whereas speed is a scalar quantity. Therefore, we'll say that we'll simply get the speed when t is equals to a quarter, which is the same as saying getting the velocity when t is equals to a quarter seconds. That is what we are calling the maximum speed. Therefore, we'll get v when t is equals to a quarter second. So v when t is equals to a quarter second will be given by, so our equation for v, we already had it somewhere. So this was our v. Our v was 3 plus 3t. So this was 3 plus 3t, 3 plus 3t, then of course minus 6t squared, minus 6t squared. So the v when t is equals to a quarter will be equal to 3 plus 3 into t. Our t is a quarter, then of course minus 6 into t squared. So this is a quarter squared. So our v will be given by 3 plus, this is 3 over 4, then minus 6 into a quarter squared. This will give us 1 over 16. So v is equals to 3 plus 3 over 4, then minus 6 over 16. So if you feed this on the calculator, you'll get your v being equal to 3 whole number, 3 over 8 meters per second, or v can also be given by 3.375 meters per second, because this is velocity. Therefore, that was the maximum speed attained, 3.375 meters per second. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.